speaker, and then we'll have time again at the end for more questions too. Oh, we do have a question. Ben asks, why did you choose to do this study for retail sales?
I think the main reason was that during the pandemic, there was there's much more of a use of TCs in the annual reviews. I think there was just some general curiosity of what kind of rate is better. So you just stick with the default, or do you change it? And I think in other surveys, there's a similar question as well.
Okay. I think we should have some time at the end also if people think of additional questions. But now let's move on to Pei Geng, and my apologies if I'm saying that incorrectly, from the University of New Hampshire. And this is an application of functional coefficient autoregressive modeling in cybersecurity. And Pei, I saw you were connected.
Yes.
Okay.
Let me find.
Can you share your screen or your slides?
Yeah. I just found the spot. I need to change my setting a little bit. Do you see my slides?
Yes.
Okay. Yeah, thank you very much, Kathy. Yeah, you are right about my name. My name is Pei Geng. I'm an assistant professor at Department of Mathematics and Statistics in University of New Hampshire. I want to thank the committee for accepting my abstract of the presentation. It's my pleasure to give this presentation at the workshop. Although my presentation actually doesn't involve seasonal adjustment. But this is a application of time series models in cybersecurity. So I want to use this opportunity to present some of my latest work. All right, let's get into this. First, first, just a brief introduction about data breaches in cybersecurity. So this graph basically shows a timeline of the latest
Hey, I'm
data
sorry to
breaches.
interrupt, but I'm not seeing your slides.
Oh.
Are others seeing the slides advance? I'm not seeing them advance. Are you in the full?
Let me, because I tried to go for full screen, then maybe that doesn't work. How about now?
I see that, yes.
Okay, great. Thank you. So yeah, this is a graph. This is basically a snapshot that I took from this website about the timeline of the latest data breaches. Each bubble represents a data breach incidence, and the bigger the bubble, then the more severe or more user records are lost. So you can see there are quite a few really big ones. Yeah, there are also some smaller ones. So basically, we want to look at the data breach incidents. So here first, just some basic information about data breaches. We do have different types of data breaches, ranging from the data records lost by using debit or credit cards, or by hacking. Hacking is a big category, and then by insider, or some physical paper documents are lost, or portable devices, and then there are a couple more. So here, the next slide I show, this is the kind of the distribution for different types of data breaches. We do see the hacking incidents are pretty big, although the biggest is unknown, because it's just the way this database collects the data, so it's kind of hard to identify them. So there are some are in the last category, but we do see different categories all have some incidents in there. And then over the timeline, I apologize for the noise my dog makes. He sees someone outside. So coming back to the graph, so this is the kind of time plot of different types of data breaches occur over time. So then just I will go to a more detail over this, but then next is the sectors of the different data breaches. We do have some from businesses, some from educational institutions, and then government or healthcare. So it really depends on what particular data analysis you are interested in. You can definitely dive into particular fields to do the analysis. So there are lots of potentials in this topic. And then I want to also show, this is the graph for different sectors. And we do see some businesses definitely have more data breaching incidents, and then medical fields also have a big portion of it. And this is the kind of the timeline regarding different sectors of the data breach incidents. Now I want to talk about the motivation for me to do this project. So first, we definitely see the data breaches is becoming more and more obvious for people. So to be aware of is definitely an issue because of different reasons. Some could be just the security control, or we do see some hacking incidents or insider jobs, and maybe also engineering techniques. So, and then the cost of a data breach report 2024 by IBM, they showed that the average cost for a data breach is about 4.88 million. So that's again increase from last year. So it looked like over the last 5 year-ish, so IBM released this report. It looked like every year they are increasing. So far, this is the highest they estimated this year. And also for the study of the modeling data breach incidents, this will also shed light to approaches to mitigate the damages. For some of, especially for companies, if they do consider this could be a risk for them, they could consider cyber insurance. So then the development of accurate cyber risk metrics will be very valuable for them to give reasonable insurance rates. So that's my motivation. I also looked at some recent developments in the modeling of data breaches. So for data breach records, people in general think about two things, two directions. One is the data breach size. say how many data, how much user information they lose. Of course, the more they lose, the more risk or more damage it could make. So data breach size is the one variable we usually are interested in. The other is about the frequency and also inter-arrival time. So that means if you consider one particular company, you might be interested when will the incident happen. So that would be about the timing of the incidents. So in the past, the people have done some particular distributions. For example, people, Edward and all, they used a log normal distribution to model the data breach size. And also they look at the frequency using a negative binomial distribution. And then later, people also study different types of data breach records for using different distribution. And then later on, regarding the autocorrelations, then Xu and all in 2018 developed the stochastic process approach using autoregressive conditional mean models for the inter-arrival time and using a Arma-Gauge model for the breach sizes. And then getting closer and closer, so people start using different distributions. So this 2020 paper used hurdle Poisson for frequency and then used some heavy tail distribution for the severity. And then I think the latest one I find is this 2022 article. They actually they developed a predictive modeling using different, quite a few factors to model the data breach size and occurrence. Then now I want to dive into the project I do here. So first, I want to talk about the data set. So I got the data set from this public website called Privacy Rights Clearinghouse. They have the database for the incidents they collected. Of course, then the incidents are not exhaustive because many times they collect data from social media, but if it is not available in social media, then they may not be able to collect it. So my data is only downloaded from this website. Particularly, I look at the time window, January 2010 to November 2018. I looked at the monthly data records. Actually, they do have the exact days for the raw data. For me to make this easier, I had two choices. Either I can look at the weekly data breach records or the monthly. But sometimes if you do weekly, there could be quite some zeros in there. So I decided to make this window a little bigger. So for monthly, we do get all observations for each month. And then this would be our time series to analyze. On top of the data breach records, I also collected this common vulnerability and exposure records, which provides a measure of cybersecurity vulnerability. So this CVE will serve as a covariate or a predictor. So in general, this vulnerability measure basically means the higher this number is, then they could have more risk to be hacked. So usually so big companies, they do tend to have this number in. That just means how vulnerable their system could be for a certain day or certain amount of time. If they know they have a patch that they know that could be a bug, but they haven't had the time to fix it, then they know it's vulnerable. So that's how this data is collected. Again, I also have the monthly vulnerability data downloaded from the National Vulnerability Database. So then we actually, for this project, I look at all type of data breach incidents. So I did not look at any particular, but we do, so we could dive into a particular type, but I look at the grand total. All right, so this graph shows you just the original time series. So you can see it looked like before 2016 is pretty stable, and there are not very big size of data breach. But from 2016 to 18, we do have some big spikes over there. So that's because I think one was a big financial data breach incidents. So then we do have some spike over here. For me, the way to handle this is I actually did log transformation for the series to make it relatively more stable. So this is some pre-processing I did. First, I took the log transformation. I actually did the log for both of the data breach records and also the CVE covariate. And then I performed a linear regression on time to remove the time trend. Because when I did this, it does look like over time, there seems to be a trend. There tend to be more and more incidents over time. So I also removed the time trend. And then I used the residual as the stationary time series to analyze. So which is the bottom one here. So I also did a Dickey-Fuller test for the stationarity of the residuals, which looks fine. So then this will be my final time series to model. Then just a quick look about the vulnerability. Oh, Kathy, do you mean there is 5 minutes left? Oh, okay.
5 minutes.
I see. Oh, I see. For the cybersecurity, this is the overall pattern. I didn't do much about this, but then I do want to move on to the models I have here. Given the time limit, I'll just move on to, I think I showed these 3 type of models. The first one is the classic AR model, and then I have the functional AR model, which means my parameters are associated to a covariate. In here, that would be the vulnerability measure. Then the third one would be the same model, but also I assume on top of the data breach records, there is additional measurement error in there. So that's my 3 models. And then my goal is to estimate these parameters or coefficients. So in the AR model, it's pretty straightforward. There are lots of methods to estimate. So I will show you in a moment how this is done. Then for the FAR, the functional AR model, I have this local linear estimation, which is an existing method. We used basically the local linear form to estimate the coefficients. And nicely, there is a closed form for the estimation. So we can just plug in the formula to get the estimators. And another one, this is actually the method that I developed in 2022. This is more a methodological article. And that means, so when I assume the data breach records are observed with errors, then I need to do some bias correction on the estimator that I just introduced, which means I derived the bias term, then I subtract the bias term from the original local linear estimator. So then in that sense, I have 3 models and I have 3 methods to estimate the coefficients. Then for AR model, we know we need to first decide the degree or what lags should we look at. So I did the ACF and PACF, particularly look at the PACF. For the AR model, I decided to use the second lag. So then my specific model would be just the second lag in the model. So using the three models and the corresponding estimation methods, I actually have the final estimator here. So this solid flat line is the AR. So that means in the traditional AR2, this is the theta2 value. That's just about negative 0.2. But for the other two models, because they have varying coefficients, so that means the coefficients would change according to the value of the covariate CVE. So then the difference is, I would say this curve, the dotted curve here would be the one with the local linear estimator, and the dashed one would be the one on top with my method that I developed in 2022. So you do see they do follow similar trend. That means when the CVE variable is smaller, then we tend to have kind of positive coefficient. And then when this is bigger, we would have negative coefficient, even smaller than the estimated from AR model. So, but my method does provide a kind of more variation in the end, which may not be very desirable sometimes if you compare to the other one. But so this is some exploration that I did. And here I show if we do look at the three models, we compare the fitted mean square error. My method actually produced the smallest mean square error compared to the other two, although the improvement from the traditional FAR is not a whole lot. Still, it do see a slight improvement. I think this, pretty much finished my presentation. This is the key reference I used in this presentation. Thank you.
Thank you. Finished right on time. Okay, so